Hello.
Hi, Chris. Can you see and hear us okay?
I can see your great big presentation, yes, but I
Yeah.
can't. You guys are small. Hold on. I have a camera too.
We can also stop sharing the presentation if we need to show you all the different rocket parts and everything. I've got my computer set up with a presentation in case we want to run through that. And then I have my iPad, so you can kind of move around pretty easily to the other components and show you all of
All
those.
right. Hold on. Let's see if this works. There we go.
Awesome.
So yes, so it's great that you have a presentation, but I'm kind of a quick, short and sweet kind of guy.
Okay,
So
gotcha.
I I absolutely don't discourage the fact that you've got a presentation ready, and I would certainly like to hear an outline. You have an outline of this presentation?
Yeah, I mean, mostly it's kind of just running through all of our parts for structures, recovery, and avionics,
Perfect.
all
Okay.
the flight critical ones, and
Okay.
propulsion.
Excellent. So some people
We
want to
can
tell
just
me all
talk through
about,
it.
yeah, some people want to tell me all about the project, and I'm like, uh, if I'm being really blunt, I want to see the rail buttons and how they're
Yeah.
attached. I want to see the couplers. I want to know about your motor, and I want to talk about your ejection charges.
Okay,
And
gotcha. Um,
really, kind of, if it's what is yours? Is yours a 30K or is it a 10K?
30K SRAD. Yep.
Okay, so 30K, then we're also going to want to see and talk about fins and what y'all did there.
Okay. Yeah, I will say just ahead of time, our fin can actually arrives tomorrow. Really wanted to have it in time for this. If you want any pictures after the fact, I could definitely send them. Um,
So, well, I think that will be something that we'll want to talk through then to make sure. So, look, we want you guys to come out and fly a rocket,
yeah,
have a good time, and do it safely, right? Like that's really at the end of the day, that's what we're really striving to have people do here. But it does need to be done safely,
yeah,
and
for
we
sure.
want to make sure that you have the highest possible chance of success, and not show up to an event where there's major concerns or issues that you'd have to try to like build a rocket in the dirt while
Yeah,
you're that is not a fun experience for anyone, and it's not necessarily even safe. So
for
um,
sure. Completely agree with that. I wish we had that in. We can talk through it and send photos later, but we can
okay,
talk through the rocket. Um,
perfect.
I guess I'll go ahead and stop sharing. We don't need to run through the presentation, no need to have it up. I know we're still waiting for our mentor and flyer of record to join the meeting. Do you want to wait for him? Because I know they're supposed to be here for that. So,
They're supposed to be
sorry.
here, and who is your flyer record?
Todd Knight.
Todd Knight. um I mean, yes, and I'm not trying to skirt that system either, but like there's a couple of cases where I've got one because of time zones and everybody wanted to do Thursday, and oh my
Oh,
God, it's
great.
been, yeah, I've got lessons learned that everyone will send me calendar invites, and I will not commit to anything until someone has provided calendar invites
Right,
next
gotcha.
year.
Yeah, sorry we didn't do that. I should have blocked it off for you.
Yeah, sorry, like it's not, that's on me too. I but anyway, looks like he has joined.
Yeah, it looks like Todd's here.
Most of us,
Yeah.
or a lot of us, have worked with one another, flown with one another, um, know each other by reputation. Not always, um, but anyway, we're grumpy old men. A lot of us. Um,
To
we won't
us.
fly won't fly a big stupid rocket without making sure that it's got the necessary safety pieces. So I trust most flyer records. But he's here. So,
Yep,
all
should
right.
be good to go then.
So let's, you said you don't get a fin can. So tell me what's going on there
Yeah,
with,
so I actually can probably pull up a picture from the presentation. I know I just stopped sharing that, but that might be
okay,
another.
no, go ahead. If you've got pictures of it, then, and
Yeah,
let's
let
talk
me
this
get
fin
to the
can.
right window and then I'll go ahead and share that. Basically, yeah, it's a fin can that attaches to our aluminum motor tube. We can show you the motor tube in person. We've used a really similar design for the last few years.
Are they just bolt on fins?
Yep, it's a bolt-on fin can. Yeah, just bolts right into the aluminum motor tube. Kind of compression. I know Corey, you can
Okay,
talk about
so
that if you want to, but
It's the Mike Fisher one.
yeah,
yeah,
I
binder
was gonna say,
design.
is it the Fisher fin can? Yeah, it was like, so sub minimum diameter Fisher fin can, metal fins. What's your actual speed? Your peak speed? Max Q?
Yep. So our max velocity is like Mach 2.02 to get exact there, I guess. And then
Wow. So you're at Mach 2.
yeah, just over it. All right, got the picture pulled up. So let me go ahead and share that now. It's been a little weird with the screen share, so let me try that again. All right, just have the presentation up, not really in presentation mode or anything. It's not super fancy.
Okay, yeah.
But
So,
here's a
yeah,
little model of it here. Can you see it all okay?
I can. And so that one of the questions I always have with a sub minimum diameter type of thing is how are you, there's always a rail button question
Yeah.
Down at the bottom. And I see that I guess it's metal welded on something or other for a bolting on that rail button with a standoff.
Yeah, that'll be the plan. We actually asked a Hero X question on the forum just to make sure it'd be okay, but we're going to use an aluminum structural piece that's welded to the fin can. And then it's going to have a 3D printed like shroud just for aerodynamic purposes. But the main structure.
Okay. So you got a aerodynamic shroud protecting the welded metal component.
Yeah.
Okay.
Yep. You can kind of see it in this photo here. I can make it a little bigger for you if you want. Wish we had one to show you in person. I am sorry about
That's
that.
okay.
But this is next best thing that we got here.
We play the cards we're dealt, right?
Yeah, pretty much. Always a game between waiting for finance and shipping and just getting things figured out on our end too.
Cool.
But no, that was a
All
question.
right. I'm good with your fence.
All right, awesome.
And I'm good with that rail buttons mount point. How many rail buttons do you have on the vehicle total?
2 rail buttons. We have one attaching to our body tube as well.
Okay.
Got the
So that is a
body.
very long motor.
Yeah, it is. It's about 58 inches in length. We're not using the entire thing. We've got a spacer in there. But it is definitely longer, although it is a little bit shorter than our motor last year, surprisingly.
Okay. Show me how does the rocket then just sit on top of that, or does it slide down over that motor tube?
We can show you some more pieces here. We can show you our coupler. I'll pull that up for you real quick.
Okay.
Yeah. We're taking our air brakes assembly out of it, but we have this aluminum coupler here. We've got the rocket kind of taken apart so we can show you all the individual parts. So this is a float bearing coupler that obviously transitions down. So motor tube bolts in here. We got a 3/8 inch bolt that goes into the forward closure on the motor tube. Body tube and transition piece bolt in on here. Body tube bolts in both above and below the air brakes. So there's also some bolt holes on our top plate for the air brakes. We can show you those too if you want. But
well, actually, what I'm trying to do right now is focus on rail buttons. So where's the second rail button go?
Yeah, so it should be pull up.
Just bolts directly into the aluminum coupler.
All right, so it's a bolt in, and so the reason I'm asking that is why.
Make sure it's not gonna fall off on ascent.
Well, I really want to know the distance between the rail buttons.
Okay, gotcha. Yeah, I probably should have that exact distance down. We can measure it out.
It's okay. Just so the follow-up question I have is, see, how long is your rail?
17 feet.
Okay. But when do you lose rail button stability? How many effective feet of rail do you have?
Got our bottom one pretty close to the bottom of the rocket. I mean, it's a little bit off, so probably a couple feet less than that. And then we've got the second rail button about 6 feet above the lower one. So you've got that.
So that's what's important, right? Is to do the math. Like take the total distance and do the math on that, because when the first rail button comes out of the rail, you no longer have stability, right? So that's the point at which you need to have achieved stable flight, right? Now, if you got something that's going Mach 2, like tell me about the motor and sort of what's the burn time on that thing?
Yeah, I got it on here too. Can just pull up the time real quick. It's an O motor. Rail velocity is about 101 feet per second off the rod. Stability, our minimum margin's like 1.65. So we have a little bit of room over the minimum there. Should be in here. Yep, so burn time's just over 5.5 seconds.
Okay. Yeah, that's a pretty Haas motor there.
Yeah.
What's the thrust to weight ratio?
Thrust to weight, can pull it up on Open Rocket real quick. Don't have that in the presentation. No, it's pretty high, but let's see.
But you say, yeah, because if you're achieving 100 feet per second off the rail, moving pretty,
Right.
low
Yep,
pressure.
thrust to weight is 12.6 to 1.
Yeah,
Pretty
that'll
high.
be a good motor. That's a good motor to fly in the wind.
Yeah, we had a test it on an open rocket and like up to like 20 meters per second because I think you can expect some pretty high winds out there.
Yeah,
I'm pretty sure that's kind of where they cut you off, right? It's like 20 feet per second. I think I said
20 miles an hour.
20 miles per hour.
Actually, this year it's going to be 18. They're going to make
Okay,
sure
gotcha.
they've got some extra safety margin.
Yeah, lower it down a little bit. Yeah, tested at some high speeds and open rocket. Just make sure we're all gonna be all good there with our stability margin, at least as far
Excellent. This is a propellant you guys have mixed.
Yeah, so it's one we did a couple years ago. Todd and our propulsion lead Adby could probably tell you a little bit more about that. They tested a couple years ago. We're looking to static fire this week. We got rained out earlier this week. Really wanted to have that done before this meeting too. And now we're aiming for tomorrow, but the weather's not looking great again. So hopefully we can get it in soon. But yeah, we included some test data on the third progress report from a couple years ago. I know it's pretty late. We're sorry about that, but
well, so look, again, we want you to fly a rocket successfully, right? And I mean, things happen. We understand there's all kinds of, I understand anyway. It would be best if we met deadlines, but there are, we had a team test fire something and burn 40 acres. So we are not going to get in a hurry to do something and then cause damage or problems, right? So that don't get in a hurry. These are big motors. There are a lot of energy, a lot of potential, right? Take your time, do it safely. That's really the whole mantra here.
Yeah, for sure.
Okay, so I'm okay with the fact that you haven't test fired. I appreciate the same thing. I mentor a team UTSA here in Texas, and they're having similar challenges, and they actually did test fire a motor, and good thing they did because they blew the nozzle off.
Oh no.
So yeah. Is this a propellant that you have used in the past or your team has used in the past and it has been characterized?
Yeah, it was used 2 years ago, at least for static fire.
Okay, so I feel a lot more comfortable about that. It's just a timing thing now, and you just need to assemble it and do it, right?
Yeah, we're pretty much ready to go. We've got the grains glued in and everything, just waiting for the weather to turn our way.
Okay. So you said you glued the grains?
Yeah, yes, they're all in the liner. We can show you some of the motor hardware if you want to get into that now. I don't know if they're going a different direction, but still got to put them into the motor tube.
Okay.
But I mean, that doesn't take too long, so I just got to grease up and.
Gotcha. Is it a 4-inch diameter motor, or what's the diameter?
4-inch diameter.
Is it a solid single piece, like graphite nozzle, or?
Yeah, you have one graphite nozzle. We've got it in like a boat tail nozzle carrier. So kind of down on the end there.
So you did use a carrier?
Yeah, I can show you right here. So you've got this, like the boat tail going in the bottom of the motor tube and holding the nozzle in. But yep.
Okay. Is it a Frankenstein motor, or is it, you even know what that means?
I actually do. I'm not super familiar with Frankenstein. Todd might know what that means.
So I mean, Frankenstein's that whatever mythical movie creature that had the bolts had the bolts in his neck, right? And so a Frankenstein motor is one that has bolts that hold the motor together versus a snap ring motor that has snap ring grooves.
Yeah, we've got snap rings. Not a Frankenstein motor then, I guess.
Gotcha.
Hey, Chris.
Yes, sir.
It's the Jerry McKinley motor, the one he uses in that Obsidian kit that he builds, the sub minimum diameter.
Okay.
So it's an actual 4-inch inside dimension as opposed to 98 millimeters. So we get a little more propellant. So it does thread in from both sides.
I got you. Okay. I think I'm good on that then.
Awesome.
What else? Let's see. So we've talked about rail buttons. I think rail buttons are okay. We do have a pretty decent length between the rail buttons, something to make sure that you are at least cognizant of and are able to explain to the safety reviewer on site. Be prepared to understand the implications of that. I don't have any issue with the fin can, metal fins, or, I mean, there are other parts of the rocket that are likely going to experience a failure at speed when you have metal fins, right? Fins, you understand the concern with the fins, right?
Yeah, with fin flutter, and then just don't want
Yes.
them to break off, obviously.
Yeah, like it's sort of kind of in my opinion, it goes like this. Like, can I put the rocket on the rail and will it stay on the rail? Right? There's one problem. Need to
One
make
check.
sure that that's true. Then I need to make sure I can get the motor lit. And then once I've got the motor lit, I need to keep the pointy end up, right?
Yeah.
And then the most important thing, if those things have happened, in my opinion, the most important thing is what? Can you tell me?
I mean, making sure your structure is strong enough for sure. We had that problem last year. I mean, that
Well,
includes basically everything with fins. I
So
mean, fin flutter, obviously, and then all of
when
our carbon fiber pieces.
when you send a rocket like this size up,
Mhm.
it's going to come down.
Yeah, one way or another, it will.
It's going to come down. And so my thing that I get real sticky on is at apogee, you need to render it aerodynamically unviable. Because even if it comes down, without parachutes, if it comes down as two parts, it will not come down near the speed of sound.
Yeah, ballistic.
People can see it and they can get out of the way.
Mhm.
If it isn't rendered aerodynamically unviable at apogee, then that becomes very dangerous.
Yeah. Yeah, no, we were out recovering last year. We had some rockets come down ballistic near us, and that was definitely a pretty scary experience. So
Yeah.
definitely try to avoid that.
All right. So talk to me about your couplers. You had that one coupler that you showed me. What's the when the body tube goes on that, is it bolted to that?
Yeah, so we've got I don't know if you want to talk through this, Corey. You can have our structures lead kind of talk through it.
Yeah, the body tube bolts on to the coupler from the outside, kind of radially bolted around.
Okay.
Um,
And how much body tube slides over that?
there is so 6-inch diameter, so 3-inch body tube slides over.
3 inches of tube over that? Okay.
The bottom's got 3 inches for the transition piece on the other side.
Oh, gotcha. Does that bolt on as well, or?
Yep, bolts on as well.
Mhm.
Okay. You may get some questions about that. Just
Mhm.
so you know, like we like to see, a decent amount of length. You've already experienced it. You already told me. Oh, you had your rocket, in a high dynamic max Q, rocket folded in half, right?
Yes. Issue with
And
our nose cone being undersized last year, so
okay,
able to diagnose that one. But yeah,
okay,
we've done a coupler similar to this, I guess, in the past with successful flights as well. Not just
okay.
our last year our disassembly in the air, as we kind of call it sometimes. Um,
Yes.
yeah. And I know there's like a 1.5 times like the diameter rule for couplers, but I think that this was not subject to that. Read something
Well,
on the forum with that.
when you bolt them together, when you're using bolted things, there's a little bit different thought process there.
Mhm.
When you have slip couplers with shear pins and it is intended to be a separation joint
Yeah.
for something like an apogee, charge, or for a main parachute, then we definitely want to look at an absolute minimum of 1 caliber. And you mentioned 1.5, and I'm kind of the 1.5 caliber opinion when you have, something that's well above Mach 1. That's just a rule of thumb. It's not, I don't think it's in the DTAG or whatever, but it's an experienced rocketeer telling you bad things happen when you violate some of those guidelines.
Mhm.
Okay, so you've got that. What kind of tube are you using? You using COTS tube or?
SRAT's carbon fiber. We've got 6 layers. Can pull it up right here. It's not painted yet. I know you know about our crash at test launch a while back, so we managed to rebuild everything, but not all of it's quite.
Well, I'm not grading paint. I'm not here to grade your paint.
Yeah.
So you said it's carbon fiber, 6 wraps. What weight?
I've got that in here real quick. About 2.3 pounds.
2.3. Okay.
Yep.
And then is it a like a 45 mesh, crosshatch, or is it just straight square?
Straight
know?
square.
Straight. Okay. Have you ever done failure test on it? I'm not sure that that's necessary, but
we haven't done, I guess, failure tests on the entire body tube before. We did material testing and a load frame with like tensile and compression testing,
Okay.
just to get some material data there. And then we've used FEA on it just to validate that it can withstand the expected loads on it.
Gotcha. Okay. Well, one of the things that people don't account for is that the wind. So what is your stability margin? How many calipers of stability?
Minimum's about 1.65.
1.65. Okay. That's like really pretty ideal.
Mhm.
People go a little over sometimes, and that can generate other problems.
Yeah, start being
And
overseas.
certainly under is a big problem because you get the pointy end not going up if
Yeah.
you're kind of low. But do you know what happens if you're too high?
Yeah, start weathercocking into the one.
You weathercock. Why is that a problem?
Pointy end needs to stay up. I'm
Pointy
kidding.
end well, what happens, what people don't understand or account for a lot of times, the inexperienced folks who haven't done this, when your rocket starts flying that way, at least the pointy end is somewhat up, right? But then when it gets to apogee, it's not an apogee with more of a tail stall, it's with velocity, right?
Yeah.
And so when you fire that charge, there's a lot of new forces you may not have accounted for applied to the rocket. So
hard to get the nose cone to pop off.
well, or if it separates and a drogue parachute comes out, it's got a lot of basically forward velocity. And so it causes zippers and parachutes to shred and those types of things. So there are ways to combat that. You've got a pretty robust motor. So even if you had a higher margin, higher caliper, of stability, with a higher thrust motor and faster off the rail, the likelihood that it weathercocks as much, it goes down. Let me see your harness, your recovery harness.
You want to pull that up, Kevin?
Yeah, there's a good amount of it. Well, there's two parts. I guess I'll show you both.
Do you want me to bring the computer over there or anything? Okay. We got all of our parts on the table over here. Trying to find the best way to show you.
I have it partially integrated here. Sure. On demonstration. So we have single separation dual deployment, as I'm sure you know. So we have a SRAD deployment bag here. So basically this is about 2 feet from the recovery bulkhead. And so we have this deployment bag, we have a deployment sleeve, a release line, and a main shock cord. When we're under drogue descent, basically this release line is under tension. This is 800-pound 1/8-inch Kevlar shock cord, and it attaches to this SRAD line release mechanism. So essentially it is
cable cutter.
What?
It's like a cable cutter, they call them?
No. It's like a latch. So
okay.
Essentially there's a sewn loop that pretty much goes around this little latch. And we have two pyrotechnic pins, 1/4-inch diameter, that when they fire, if either one fires, it releases this latch. We've done ground testing on it. So we've tested it at 3 times our expected load. So since it's got some sort of mechanical advantage, if you will, since the release line attaches at 2 points on the rocket, basically the one end attaches to the mechanism. I'm going to point this down a little bit.
Yeah, feel free to use the iPad to show us.
Oh yeah. So the one end attaches to the PLRM, as we call it, pyrotechnic line release mechanism. And the other end attaches to this threaded link that connects directly to the U-bolt. And so essentially it's only going to be ever experiencing half the load as what the drogue shock cord will experience. So when I say 3 times expected load, that's 3 times half the weight of the rocket under drogue descent. So that's about, I think, 60, 70 pounds we did like a 65-pound weight and 70-pound weight. We did multiple different weights just because we have a lot of spare weights laying around. And so essentially that release line just slides through this bag, opens up, deploys our main canopy, right? And that's stored in here. A problem we had at test launch last year was our main shock cord and shroud lines would get basically loose from the bag and tangle up and kind of choke the bag, so it wouldn't be able to release our parachute. So we would come down and land under drogue, suboptimal, if you would, imagine. So essentially, one of the biggest things was retaining those lines. So something I learned from skydivers and like U.S. Air Force riggers is they use these rubber bands basically. And so I'm using a combination of tape and rubber bands to retain these lines, basically so that it keeps it as one big bundled ball inside the deployment bag so that no amount of line can come out. And once it is actually under tension, I mean, 60 pounds of rocket is going to break this apart. We've tested this. We have this testing method, like I call them car tests, but essentially I have this structure that I strap to the top of my van, and it's basically a fully integrated recovery system that we initiate manually. So basically just a 9-volt and an E-match, right? So, I mean, we want to think about maybe doing some avionics initiated ones based on some test launch experiences, just with like weird short circuit stuff, because, E-matches in a metal block, that's now a concern. So we're looking at insulating that. Anyways, we're talking about the harness, so we'll move up. So we've got our deployment bag, we've got our main canopy, shock cord. This is 5,000-pound Kevlar line for our main shock
Yeah,
cord.
that was the piece I wanted to see. Thank you.
Oh yeah, yeah.
Running through it all.
So
well, I want to see all of it. I want to understand all of it, but
Yeah.
but definitely the size of the shock cord is
Yeah.
is the main.
yeah, and then on one end it's sewn. This is hand sewn, but we did we've got a person who's really good at sewing on our recovery team, but I forget what kind of stitch it was that they did on this, but it's not going anywhere. It's also redundant, so it's got 2 points where it's stitched. And then also to absorb loads, just in case there is a large snap force, just a large amount of acceleration over a very short period of time. There's this TPU snubber inside that deployment sleeve. So essentially, I don't know if you've like been boating or anything, but like if you're moored up to a dock or something, and the boat's in the waves and you don't want to snap your bow line, you use a snubber. So it basically just spreads that impulse over a greater period of time, thus reducing your force. This is 3D printed out of TPU. We've tested it under load, and the great thing is if it breaks, the shock cord is still fully intact and connected, so it doesn't affect anything, and it's contained within the sleeve, so there's no debris. And as we move up to our drogue line, I ended up upgrading this. This was also that 800-pound line previously, but based on calculations, I wasn't expecting us to ever exceed an 800-pound force, but the size of the line was just giving me like angst. So I upgraded it to 1,200-pound line. Because it's like, you're looking at an 1/8-inch shock cord and you're like, there's no way that's going to handle 800 pounds. It's Kevlar. Sure it will. But this is I think we're 60 pounds at launch, right? Or nearly 55 pounds at launch. So
well, after
like
motor, we're about almost 80 with the motor.
Oh, okay. So 80 pounds at launch. It's like, okay, well, I don't know at that point. This isn't our planned competition drogue. We were gonna use this for test launch. We've used it before. It's just a 5-foot diameter, like open top, hemispherical or something.
Almost looks sacrificial the way I know drogues get beat up.
But yeah, so we had a ballistic recovery on our test launch. So our drogue ended up deploying at 1,500 feet due to we diagnosed it as a wiring issue. I'm still not 100% sure of the exact cause, but it was believed to be a wiring issue and something with avionics and recovery mix-up.
So that seems to be like an area you might want to focus, right? And I guess the question I have is, what electronics are you flying?
You can get our avionics lead over here for that.
So, the current plan, we mentioned this in our technical report. We've been developing an asteroid flight computer that may possibly fly this year, but so we're doing one more test launch. We're going to fly that in sort of a passive mode to see if that functions properly. If not, And what I assume will happen is we'll be flying our two cost flight computers from Altus Metrum. So they're mounted on top of this, which is I can take this off.
It's fine. I saw them. So you said Altus Metrum and what?
They're both Altus Metrums.
Okay.
Minis. So yeah, we have these mounted up here, so far away from the air brakes, so to avoid any sort of pressure anomalies caused by those. We have color-coded wiring. We have two different keyed connectors, so you cannot mix those up. Those can only be plugged in a certain way. They're different connectors, so physically they lock into their connectors. We've done some pretty rigorous testing on these cost flight computers leading up to our attempted test launch this past weekend, which we did have to scrub. But we used a vacuum chamber where we were able to lower the pressure at roughly the same, within reason, the same rate that you would see during flight. And then we were able to confirm that not only are the flight computers triggering based off of pressure, but also that verified our wiring, as we could see our charges going off in the race sequence.
Nice. Okay. Well, so it sounds like, have you flown the Altus Metrums before?
Yeah, so, well, not like these exact specific flight computers, but the same model before, yes. So
the same model. Okay, so you're familiar with that particular model. That particular device itself may not have flown, but that model you have flown before?
Yes, yeah, we've flown the same model before in the past.
All right, because that's what makes me nervous a lot of times is people get brand new electronics they've never used before, and if you're not familiar with them, you can have challenges.
Mm-hmm. Yeah, but we have used these. We've used this before.
Okay.
We used them at our test launch last year. We used them at our competition last year as well, though again there was the structural failure which prevented them from actually being used in that case. And then a different we have like multiple rocket teams. One of them competes with the NASA competition, and they also have used one of these flight computers in that.
Okay.
But yeah, we've been extremely careful following our test launch failure. We've been extremely careful with the wiring. We're every possible way to check it. We did have a different sort of wiring type issue at this test launch attempt, which we've since addressed. But that was just, one of the EMATs just shorted through the metal block as a recovery.
Yeah.
And so we've come up with mitigation measures for that.
All right. So just one point, you are aware of the battery rules or whatever, right?
Yes.
Okay.
So,
all right.
yeah,
And then the only other point I'll make, just again, as a pro tip, if you will, a guy who's learned the hard way, from experience, if you have two of the exact same system as your redundant systems on a vehicle, and you experience something that's anomalous that affects one of those systems in a bad way, you might affect both of those systems in the same bad way.
Yeah, and that's something we've been thinking about. Unfortunately, due to the test launch failure, our funds are a little bit limited right now. So, but yeah, that is like my biggest concern at the moment. Though again, we've done the testing yet, but that is something that I'm aware of and thinking about.
Okay. So did you, you've got, clearly you need one separation charge, and then you've got the release mechanism to do the remainder of the stuff, right?
Yeah. So Recovery Lead can give more details, but yes, there's one charge that fires an injection charge deployed at apogee, and then there's a second one for the main parachute, and then there's basically a duplicate of that. So there's like 2 ejection charges and then 2 main parachute release charges.
Okay. Did you pack the entire thing, all of the recovery parts, when you did your ground test?
Could you elaborate on that? So
a lot of people are showing me videos of ejection charge tests where they've got they've got nothing but the Kevlar harness attached to their nose cone. They haven't put the parachute, they haven't put, the deployment bag, they haven't done all of that, and they didn't do the ejection charge test with all of that. And then if you have like your avionics is up in the nose cone, or you're ejecting like that, like it needs to have the complete cube set and all of the things, right? Because that weight makes a difference in, the ejection, right? So a complete ejection charge test is a flight ready vehicle.
So I will say, so I think for our ejection tests, we have our integrated systems bay, but I don't think we've had our full satellite installed.
Well,
Yeah, I
that's-
guess with that, I think you're kind of talking about, are you talking about like nose cone weight and systems in the nose cone they're actually ejecting? We've had the parachute
Yeah.
and that's been packed.
Oh,
but, like,
yeah. So like the recovery system, we do fully integrated.
Okay.
I will say we don't put like in the like pyrotechnic line release mechanism, I won't put live charges. I'll just put like wires so that I can check to see if the wires are going to get pulled or something like that. We it was funny, one of our ejection tests is yielded a result that like the pins would get pulled out, but that was because I didn't fully integrate the line release mechanism because I didn't put any fake charges in there. So there are weird pressure things that went on that like pulled the pins. But that was just because they weren't sealed. But yeah, we do fully integrated recovery system with all of our ejection charges, all of our recovery harnesses, the main parachute, the drogue parachute. We have flame cloth. I'm trying to think of all the things. But yeah, so I mean, about as integrated as we can get. And then this last set of ejection tests were also avionics initiated. So we did the classic, put a vacuum pump up to the, I guess, pressure relief hole and just kind of turn it on, turn it off and see if it'll pop the nose cone. And good.
Yeah.
Nominal, I would say.
The only things that we have in our nose cone, it's just, I guess we have some stab weight up there and then it's just the parachutes, our avionics and all of that. Is in
Yeah. Yeah. Well, but what I was getting at, like from a volume perspective and a friction perspective, like, you know, well, I did an ejection charge test with just the line in there and the nose cone came off fine. Then I took a parachute and I shoved it in and I rammed it into a tube. And then when I did ejection, you know, when I flew it, like the nose cone didn't pop off or whatever. Like, well, that's because you had it packed too tightly in the tube. So that's the reason I ask.
I mean, if you don't mind me kind of just talking about this, one of our first ejection tests, it was funny you mentioned, we kind of had a very similar problem because I did the volumetric calculations just based on the geometry of our rocket, and I didn't account for the volume that the parachute would take up. So it turns out since we pack our parachute so densely in this bag to keep it kind of stable rather than like loose and wobbling around, it actually reduces the volume so significantly that we had a bulkhead failure because the pressures were too high because I didn't figure the volume calculations would be that significantly affected by it, but learned that one the interesting way.
And to elaborate on that too, we're using plywood core bulkheads after that too, just because we broke that one. So before it was honeycomb, which theoretically it's the same in compression or strong in compression, but just going the safe route and using plywood core.
Okay. What are you using for your like ejection charge wells or the powder holder?
Yeah, we have those out. I think we have small ones right now.
So
These are smaller than our typical ones. The actual ones that we have are
okay, but they're metal, they're aluminum. Yeah.
Yeah, and
Okay.
they're long.
Yeah, I can go into detail about those. So we have 4-inch long, I think 3/4 inch approximately diameter. I think it's 0.8 to be exact, but I think we did it in metric.
Okay.
So we have a surgical tubing section, I guess, sealed at both ends with hot glue and zip ties. So basically you put the E-match in, hot glue it in, and then crimp it down with a zip tie. You pour in the calculated black powder charge. For those we do, since they burn so much more efficiently than these like rocket junkie ones, we actually do 2 1/4 gram, whereas these require like 3 1/3 gram to get proper ejection. And so once we pour in the black powder, we then put the hot glue on the other end, cinch it down with a zip tie, and then seal it in the ejection canister, and then tape the whole thing down so that it's not loose. So we've done ejection tests with those as well, but those have been misplaced on a spring cleaning event. So that was
that's okay. I want to make sure that you've got some sort of containment for the charge and it's not flopping around, getting cut open,
definitely.
right? Is you got the plastic, the glove in there bouncing around, getting chopped up by the pieces of harness or whatever. That's one thing. And then some people leave, you know, they'll take those aluminum canisters and they'll just leave them loose, and they'll punch a hole through the side of your rocket tube if you aim correctly. So
definitely bolted down for sure.
yeah, bolted down and pointed up, right?
Yeah,
Pointed
pointed up. Everything's gonna be pointed up.
Yep.
Right.
Really.
Excellent. Okay. What else did you guys want to tell me about?
I think we covered the issues that we had previously with like the stability margin and the rail buttons. I guess we can show you some other structural components if you're interested. I know you said you have a couple other meetings today, so I don't want to take too much of your time. Do you guys have
Well,
anything you'd like to add?
Anything your flyer of record is worried about?
I want to see deployment.
Yeah.
Just because it's been safe, but that complicated release mechanism, I want to see that work in a real flight application. That's the one thing I'm worried about. The up part's going to work good. The motor's good, but I've done enough head-end deployments over the years that I know they just don't work all the time. So I want to see this work when it's in a flight mode.
And we've got a test launch planned for Wednesday of next week, assuming weather holds. So we'll have a test for that hopefully within the next week with recovery and everything.
Outstanding. All right. Some of the other items that they'd like us to at least touch on or remind you about, things like, clearly you guys, so people that are buying motors may or may not have their motor yet, and they need to make sure that they're going to have a motor when they get there. Sounds like you probably have that sorted out. Your accommodations, so you know how many people you're taking. Everybody's got, you guys don't have visa problems clearly, but do you have a place that you're staying?
Yes,
Where
got
are
a
you
hotel
staying?
and vans booked for the drive, so all good there.
Okay. All right. Excellent. Like my team wants to bring in a demo grain or demo, like, and so if there are no energetics. We say this repeatedly, there are no energetics at the convention center. And if you are going to be like my team and bring in a mock something or other, it should be clearly labeled as inert and non-energetic. So keep that in mind, because you don't want some people flipping their lids. Okay, so no energetics, no black powder, no grains, no none of that for the inspection. They want as complete of a rocket as possible with no energetics. Battery mounts. So make sure that you have really good, I've seen a number of times where, a high dynamic flight has, a duct tape or is one zip tie holding the battery on versus a nice battery holder or something like that.
Yeah, our batteries, they're secured with command strips, and then also there's a 3D printed enclosure that also physically restrains them.
That's great. That seems to be pretty popular with students these days, is 3D printed something or other. The only other thing I would say is if you by chance are using 9-volt batteries, I prefer to put the batteries in upside down, right? So that if there's any pull force that doesn't pull the connection off the battery's turned to upside down and is actually, during acceleration, it's being pushed together with its contacts, so that at a minimum you get your apogee charge.
Sorry.
Oh, I have flown personal rockets where that works. And I get the apogee charge, and then the rocket comes down and single deployment. And then I'm not hearing the thing beep or whatever, and the shock of the parachute opening or whatever is enough force in the other direction to disconnect batteries. So
all of our batteries, as well as the arming switches, are aligned so that they're not aligned opposite of the acceleration, so that they don't be pulled out by the burn.
Gotcha. Good. See, and so those are things that, again, the safety review people probably will look at on site. So just be aware of that. So yeah, those are the big things. Again, so you got accommodations, you got your motors, you know where you're staying, you got transportation. We want, so there's your rocket sounds head-end deployment, and I guess the other, speech that may not get said enough is, do you know the most common and typically bad injury type of thing. What causes most injuries at rocket launches?
Probably heat stroke or something.
So heat stroke is second.
Probably something with the charges when you're trying to reach down in there or something. Is that what you're saying?
No, it's really stupid. It's really stupid. So how tall is your rocket?
Oh, falling off a ladder?
Falling off a ladder, number one.
Interesting. Okay, yeah.
Falling off a ladder.
Consider
So you need a ladder that's adequate size to get to where your electronics are. Sounds like you might have.
yeah.
pretty
Those
reach.
are actually positioned so I can reach them from the ground. So.
Oh, okay, excellent.
Got
And
our,
that's
I guess our electronics are stored in the coupler, which is just directly above the motor tube.
Okay.
Not too far off the ground.
Yeah, well, except for the payload.
all right. So those, but yes, falling off a ladder seems to be one of the, I say, more popular, more common ways to injure yourself at a rocket launch. And then heat, lack of overexertion with not enough liquid consumption is next. So please try not to be that person. Watch each other and make sure that you're, you get busy, you get go fever, you forget to drink. And so somebody really needs to be kind of tasked with, hey, it's been 30 minutes. Everybody needs to get out a small bottle of water and drink it.
We assign a major hydrator every year.
I love it. Outstanding. Okay. Sounds like you've got that covered. Any questions for me?
I don't think we have any questions. I think hopefully we covered all of your concerns. I know we've had emails and from progress reports. I guess a couple things to look forward from us is just updates about how our test launch and static fires go. With the two big things we've got left to do. So
Okay.
Email you those results when we have them. But
Awesome. Well, it sounds like your flyer record wants the same kind of thing I want, right? In terms of, I want to see the harness. You guys have your car with your van or whatever, that fancy thing, but there's also, we call it the walk test. You know what the walk test is for your recovery system?
I don't know if I do. Not the exact term. Just walk with the parachute deploying.
So grab the nose. So one person holds the one end of the
Oh.
rocket, the other person grabs the nose cone, and you just walk the other direction, and make sure it deploys proper.
All right. Simple, easy enough.
It's an easy test, but it's overlooked. So, all right, excellent. Well, guys, good luck. Be safe, and then looking forward to seeing you out there at the event. You guys have the recording. They like to have a file uploaded, not a link to a YouTube
Okay.
video.
There,
I'm
I'm sure I can probably find out on HeroX, but while I've got you guys here, is there a specific spot to put that on HeroX, or is that an email sort of thing?
There is something, and I am derelict in.
I can
knowing.
find it later then. I was just
Okay.
curious if you knew off the top of your head.
I do not. I'm sorry.
No worries. All right.
Awesome.
Well, thank you so much.
Yes. Well, thank you,
for the
and
reviews.
good luck.
Have a good rest of your day.
You too. Take care.